go with the our numerical problems and all the remaining things. Okay, and now what is the gravitation? Yes, and you know very well every body in the universe attract towards the particular another body. Yes, that is only called what? That is only called as a gravitation activity. Okay, got it or not? And we already discussed it, the properties of the gravitational forces and everything we have discussed it. And before going to that, according to our gravitational system, there is every two bodies in the universe is the one is attracted with another. Every two bodies in the universe is the one is attracted with the another one with influence of one force. That force is only called what? Gravitational force. Suppose you have to take the M and another force you have to take it is a small m, and one is attracted towards another one, capital M, and another small m, one is attracted towards another one. Got it or not? I hope you got it here. Yes, and here this attraction force is directly proportional to product of its masses, and it is inversely proportional to square of the between them. This is equation number 1. This is equation number 2. And combined together, it is also written as m by r square. F is equal to taken as g into mm by r square. Yes, this is only called what? Newton gravitational law. According to the Newton gravitational law, every two bodies in the universe is the one is attracted with another one with influence of one force. That force is directly proportional to product of its masses, inversely proportional to the square of the distance between them. Okay, got it? That is only called what? Newton gravitational law. And now here in this one, there is a G is called what? G is called gravitational constant. It contained what some particular units and as well as the dimensions are also there. How do we define the G? Yes, from this one, so from this equation, it is also written as F into R square is equal to G into mm. Okay, and G is equal to taken as what? F into R square by M into M. This is the value constant. The value is equal to what? 6.67 into 10 to the power of minus. Okay, yes, 8 minus 11 Newton meter square by kg square. Okay, or 10 to the power of minus 8 9. Yes. This is only about the units of our gravitational constant. Yes, I hope you got it here. Yes, and here there is a somewhat dimensions are there for it. It contains some particular properties also. Okay, yes, everything will be already we have it. Yes, and this is only about our Newton gravitational law. Next, after this, why is the G called the universal gravitational constant? The value of the G is independent of the nature, size, and mass of interacting bodies. Yes, the space where the particles or bodies are kept, the time at which the force is considered. Okay, got it or not? And here there is a Newton meter square by kg square we are consider it is, and now that it is equal to yes, please all the students. And here, how we define the G value? When there is a 1 Newton force is acting on the body, 1 Newton force is acting on the body, which are contain 1 meter's distance between them and with the 1 kg masses. Both the masses are contained 1 kg. They are influenced by the 1 Newton force, and the distance between them 1 meter square, that is equal to the gravitational constant. And in this way only we are taken units of our gravitational constant Newton meter square kg to kg square. Got it? This is about our Newton gravitational law. and already we have it in our regular syllabus also. There is a gravitational forces. Yes, whatever characteristics and properties are there, already we are discussing here. Yes, and once again we repeated the characteristics. What are first characteristics we are discussed already earlier? There is a what is the gravitational force between the two bodies or object does not need any contact between them. It means gravitational force is an action at a distance. Yes, I hope you understood it. Yes, so when you take a gravitational force, okay, the gravitational force is a non-contact force, or otherwise it is also called what? Field force. Okay. Yes, what it is? It is called as field force. Characteristics of gravitational force. First one, gravitational force between the two bodies or object does not need any contact. Okay, you know very well. Okay, by influence of some forces of somewhat distance only, it will be working. Okay, why? Because it is a top piece. Now it will be come towards as ground. How it is possible? There is any contact is there between the earth and this top piece? No, but it will be fall down. How it is a fall down? Yes, without a contact only one force is working. Okay, there is it is a non-contact force. Somewhat distance only it is working. Yes, and as yes, gravitational force between the two bodies varies inversely proportional to the yes square of the distance between them. Already we are discussing. F is inversely proportional to the square of the distance between them. Okay, that's why only it is called the inverse square law. Inverse square law. Not only this law, already we are discussing. Yes, that is Coulomb's inverse square law and Ampere's square law. There is whatever the things are there. These all are yes depending on the distances only. Yes, and all are inversely proportional to the action of the forces are inversely proportional to the square of the distance only. Whatever field forces you are consider, electrical forces, electrostatic forces, or otherwise magnetic forces. These all are yes inversely square of direct inversely proportional to the square of the distance between them. Okay, and the next after this. What is the next component here we consider? Yes, more characteristics are also there. Gravitational force between the two bodies or objects form an action and reaction pair. If the object attract object B with the force F1 and object B attract object A with the force F2, then F1 is equal to F1 minus F2. Here, any two forces are there here. Yes, this is also giving force on this. B is also giving force on it, and as well as A is also giving force on it. In case it is giving F1, in case it is giving F2. Okay, clear or not? Only the whatever the direction compared with one another it totally different. Okay, but they are what attracting with one another with the yes, forces, same forces. That is why we can't say it is action with the reaction. It is suppose it is action, it will become reaction. Is action, it will become reaction. F1 is action, F2 become reaction. In case F2 is action with respect to B, F1 is become what it is. F1 is become reaction. Okay, got it? These are contain the pair of reaction and action forces. The gravitational force characteristics are these three. First thing is it is a field force. Means what? It is not a contact force. Second thing is it is inversely what is it is inversely proportional to the square of the distance. Second one. Third one is what? Yes, it is as acting based on a distances. Okay, clear or not? And as well as it is a reaction and action pair force. It is action and a reaction pair force. I hope you got it. Yeah, next component is the properties of gravitational forces. Properties of gravitational forces. Yeah, first thing is gravitational force does not depend on the medium like between the two bodies. Okay, whatever the thing it is there between one body to the another body, it is not depending on the whatever the medium is contained between the two bodies. Okay, example is suppose there is a sun, it is there. Yes, between the sun and earth, between the sun and okay other planet, there is somewhat mediums are there, somewhat yes vacuum is there. Okay, now yes whatever the thing it will be made there. The gravitational force of the sun is not varied. Okay, any medium it is there. Suppose without the book it is there, with the book it is there. Between the earth and okay, now this chalk piece there is a book it is there. Yes, and now it will be because of normal force of this textbook it will be messed up. But it is attracted with the same force in case the book it is there or not. In this particular condition and in this condition, there is it is attracted towards the earth with the same gravitational force only. Got it or not? But it is a stop. Why? Because normal force of this book is opposite. Yes, the weight of this piece. Got it or not? The gravitational force is not affected by the medium. Okay, clear or not? You know very well about this thing. It is also not depending on the mass of the body. Yes, and the next one, gravitational force obey the Newton's third law of motion. Yes, the gravitational force of attraction between the two bodies is a reaction and action pair. That is already we have discussed it. That is only the characteristics based on the third characteristics. It is a reaction pair. Okay, gravitational force is always attractive force only. Suppose you take here electrostatic forces, sometimes they attracted, sometimes they repelled. Okay, there is a plus and the plus charges are there, and the minus and the minus charges are there. They are repelled with one another. Okay, clear or not? Like that only magnetic forces also. Okay, yes, when there is a north and north pole, south and south pole repelled. North and south pole is attracted. But our gravitational force is not like that. Our gravitational force is always attractive only. The no word of repulsion. The no word of okay, yes, whatever the yes repulsion components. There is only attraction. Always it is attracted towards the one body with the another body. There is no repulsion is there. Got it or not? The nature of our gravitational force is always attract to only. Yes, a fourth component. Yes, what is the fourth thing? Yes, gravitational force is the weakest force above all of them. Actually, there is, we are already discussed in the last class only. Gravitational force is the weak forces compared with the remaining forces, whatever contained in the universe. So, what the forces are there more better than that? That much of force. Yeah, atomic forces, very, very strong forces. Nuclear forces, strong forces. Okay, got it or not? Yes, there is all are whatever magnetic forces, strong forces. Okay, clear or not? Yes, and here that is why only the magnets one is attracted with another one extra to the gravitational forces. The gravitational forces are only weakest forces compared with the all the forces. Got it? Or yeah, not a compare with the muscular forces, not the compare with the frictional forces. Whatever the field forces are there, nuclear forces, electrostatic forces, magnetic forces, these all are yes more greater than forces are than the our gravitational forces. Next, after this, these are only the conservative force. It is also conservative force. Conservative means it is a constant force between the two bodies. It is a constant. It is not varied depending on the masses of the bodies. Okay, clear or not? Between any two bodies, it is always constant only. Okay, clear or not? It is not changes. When it is changes, when there is a yes, distance is a changes, it is a changes. Masses are changes. Otherwise, it is remains conserved. Okay, clear or not? Yes, that is why only solar system is running by some thousands and lakhs of years ago. Otherwise, it is not conservative. it will remain fall down in a Earth is a fall down in the sun, and remaining all the planets are also fall down in the sun. Yes, why? Because there is a why, because they not fall down in the sun. Then why? Because they maintain some particular constant force between them, depending on their masses. In case there is a masses are decreases, in case there is a distances are made decreases, there is a compulsory earth fall in a sun. Okay, clear or not? In case its loss is originality, its loss is whatever evolution nature. Now, as per whatever there, that is changes that should be follow compulsory on the sun. Okay, got it? Or I hope you got it. It is. And now we are going with the what example questions. What is example questions are there? Manshi. Yes, find the gravitational force of attraction between two spherical bodies, each of mass 1 kg, placed 10 meters apart. Okay, got it or not? Here, F is equal to G into M1 and by R square based on this one we are considering. What they given? Find the gravitational force of attraction between the two spherical bodies. Each are contain 1 kg only. Both are contain 1 kg, and here also it is 1 kg. What is the distance between them? Yeah, 10 meters distance between them. Yeah, how to find out it here? F is equal to G into M by R square. Here you have to write the values. What is the G value here? G value taken as 6.67 into 10 to the power of minus 11 is Newton meter square by kg square. This is the one component, and capital M is the 1 kg, and small m is also 1 kg here. Yes, and whatever the R value is there, R value is 10 meters. Now these values are all substituted in the what we can get F value. F is equal to taken as 6.67 into 10 to the power of minus 7 into yes what 1 into 1 by what here 10 square. Yes, got it? Now it will become what actually now F is equal to taken as 6.67 into 10 to the power of minus 7 into 10 square. Then it will become outside. It will become what 6.67 into 10 to the power of minus 13 newtons. Please note down. All the students, next component. The 2 point masses M1 and M2 are kept a distance D for find the distance from M1. Yes, between M1 and M2, where a mass 1 kg experiences zero net gravitational force. Okay, 2 point masses. Here we consider M1 and M2 are kept at a distance D apart from one another. Find the distance from M1 and M2 where a mass 1 kg experiences zero net gravitational forces. Yeah, an important problem it is. That is what we are taking here. That it is taken as what M1 and also as there is we are taken M2 here and meanwhile one more mass is also there. What is that mass? We are consider it is a contain 1 kg. And now there is a force here to taken as F1 and alpha here force to taken as F2. And the total distance is the what? D we are considering. Okay, clear or not? Total distance is taken somewhat D. And here, from particularly point masses to another body mass, here we contain the distance is taken somewhat x here. Okay, clear or not? X we are considering. Now, according to the whatever the F1 is taken here, how we written it is the formula is F is equal to V into mm by r square. Here, m is equal to taken somewhat m1, yes, and here small m is equal to taken as 1 kg, yes, r is equal to taken as somewhat x. When then f is equal to f1. Okay, clear or not? Then f1 is equal to written as what? F1 is equal to written as g into m1 into 1 by r square. That is become g into m1 by r square. Okay, one equation maybe. Next, here there is a what is the distance there between f2, m2 and this particular 1 kg body? This is become yes d minus x. That is a totally d and up to here they given x and it will become d minus x. We have to find out x bar. Next, after this what is here f2 become now when f is equal to f2, m is equal to m2 and the small m is equal to taken as 1 kg, yes, and as well as r is equal to taken as d minus x. Now, F2 is equal to written as G into M2 into 1 by S. What is R value there here? D minus X whole square. Okay, got it? Yes, here it is equal to G into M2 by D minus X whole square. Got it? This is the F. Now, F1 given the what here? Given that F1 is equal to F2. The same force is only working on it. Because of that only the net force will become 0. What they given? Net gravitational force will become 0. Then here it is also written as G into M1 by x square is equal to G into M2 by yes, D minus x square. The cancel M1 by M2 is equal to taken as. Now it will become M1 by x square, M2 by D minus x whole square. Here M1 by M2 is equal to, yes, what it is become now? X square by D minus x whole square. Got it? Now here it is also written as x by both sides apply under root. Yes, now it will become what? X by d minus x is equal to what? Under root of m1 by m2. Under root is applied here. Square and will cancel get each other. Yes, both sides we are taken under root. Yes, it is the square and square cancel at each other. Now x minus d minus x is equal to under root m1 by m2. Okay, got it? Now, as after solution, what we get here? Yeah, please note on up to here. Please note on it. Note on it and conclude. I am giving here. This is the first part. This is the second part. Complete it up to here. Yeah, next component. After this, how to we solve this mathematical formulation? One second. Here, this is the third point here from here. Now, it is also written as yeah. Make it here under root of m1 by m2 it is there now, make it is like that. M2 by m. It is also written as d minus x by x. Readable or not it is? Yeah. Just I am changing the denominator into denominator into numerator. And now that it is numerator, it is taken as what? Under root of m2 by m1 is equal to taken as s d by x minus x by x. Written or not? Now it is also written as m2 by m1 is equal to s d by x minus 1. Got it? Or not? Now what we required here? X value required here. Now it is also written as d by x is equal to taken as under root of m2 by m1 is plus 1. Okay, clear? And here x is equal to taken as what? Then x is equal to taken as d by under root of m2 by m1 plus 1. This is only the yes, value of the x when there is a the problem is like this here. Yes, there is we have taken this is a one chalk piece, this is another chalk piece, and there is I am taken there is the three things like this. Okay, now what is the distance between these two things when there is a net force is acting on the gravitational force? The duster is giving gravitational force on this chalk piece. The duster is giving chalk piece whatever gravitational force on this chalk piece also. Okay, now yes, when there is a force of this one is F1, this is the F2. Okay, now F1 and F2 is both are same. At that time only F1 and F2 forces are become same, net gravitational force is same. At that time, what is the distance between them? At what distance they become? Yes, net forces become zero. That is indirectly at what distance we are maintained. At what the distance is maintained between our two masses, gravitational forces become zero due to the middle one. Okay, yes, it is used as a formula also. Yes, sometimes directly we are applied this value. Yes, for formulas purpose, they are applied the values to get the what is the distance between them. For a gravitational force of three bodies, between the three bodies are become net force become zero. Okay, got it? I hope you got it here. Yeah, all the students. Next we have a conceptual practice sheet. It will be there. Today we are going to know what a conceptual practice sheet. Yeah. Now there is a what is the concept of practice sheet? First one, the SI units of universal gravitational constant D. That is our Newton meter square by kg square. Okay, why? Because G is equal to F into R square by M into M. Okay, yes, from that one, it is you get Newton meter square by kg square. Okay, and second answer, gravitational force is the dash force among all the forces, weakest force. Okay, it is our weakest force. Already we have discussed it. It is one of the property, weakest one. Third one, gravitational force always attract two forces. It is a attractive force. And the fourth answer, two metal spheres of the same material and a radius r and are contacted with each other. The gravitational force of attraction between the sphere is the proportional to the okay, yes, it is the proportional to the distance between them. Okay, that is the diameter. Okay, suppose what they given. Okay, they given two metal spheres of same material and the radius are contacted with each other. Okay, then gravitational force between them means what? This is the radius r and they contact with one another. Yes, this is also r. Metal spheres of same material and radius is also same. Totally, what is that? 2r. Okay, now yes, it is inversely proportional to the 2r square. Okay, totally, what is that? R plus r, 2r, and here r plus r, it is equal to 2r. Then the gravitational force is inversely proportional to the 2r whole square. Means what? It is 4r square. Answer is 4r square. Next, fifth one. Mention the properties of a gravitational forces. That is the synopsis based. Okay, 5 properties are there. Okay, now you have to write it. Simple thing. There is the first thing is they're not depending on whatever the media between them, and they are repulsion pair and whatever attraction. Sorry, action and reaction pair force is a conservative force, and alveolar, it is weakest force among all of them. And last one, it is about what actually always attractive. There are 5 properties are there. Yeah, please note down these answers and write it in your notes. What is the properties of gravitational force and what is the characteristics of gravitational force? Okay. Yeah. Thank you, students. Today's class this one. Tomorrow we go with what numerical problems and gravitation. This lesson already you have in your regular syllabus. It will become as a revision for you. Yes, so don't miss it. Yes, thank you, students.